What does that mean? Okay, so I'm gonna go back here and see what's going on. Oh, excuse me. All right, now let's also do. Okay, so we're almost there, chat. Okay, so here's what we're going to do. We're going to look at, I'm going to show you a few little things, and then we're going to show you how to program this thing. So default, to program it from scratch. So no scope, pro top right. Okay. And then I also want to add a new source. Sorry. To my Firefox. Okay. Firefox. Dealing with device manager. No. Command line. Yeah, command line's working. Don't think device manager is there anymore. Oh, I see. I have to actually, it has to be up on a window. Okay. Okay. The command line. The command line is there. I'm going to add one more source, which is another tool. Okay. I'm going to just add window capture. New source. I'm going to call this source. What is this? AVR do this. All right. We're going to bring in AVR do this as well. Okay. We'll bring this in as well. Make it relatively sizable. Okay. And we can just hide that from it. Okay. So welcome back, chat. We are going to go and program this retrochip tester from scratch. We're not going to spend too long on it, but I want to show you something uh, that happened to me. So um, when you've built it, right, you're going to get to the point of powering it on. Now, when I powered it on, I did get the little LED, which was right here. This LED will come on. I'll show you what that looks like. Okay. So you power on the unit, put in your USB here. Okay, and this is a good sign. So when you plug in your USB, this light is what you want to see. Okay, so that's pretty cool. All right, but when I plugged in my programmer, it wouldn't recognize, I went through the steps, it wouldn't recognize the actual, this here, this chip, the AT2560 Mega. And so what I did was I went around the chip. Let's just do a pro top, right? I went around the chip with um, my little multimeter, and I looked to see if any of the chips were grounded. Sorry, any of the legs were grounded. Now, to know which legs should be grounded, obviously you can look it up, but it's also in the handbook. Okay, so let's just have a look here, right? We can do Firefox full. All right, and in the actual, I'm just going to scroll down because I'll see a picture of it and I'll know it when I see it. He's got a he's got a picture of the the actual chip itself. It's pretty obvious somewhere up here. Okay. Oh no, it's up here in the troubleshooting section maybe. Um, what am I doing here? All right, sorry. Where did I? It's probably right here. Okay. For the fuses? There it is. Okay. So there's a picture of the chip here. And so what I did was I probed the chip, right? So this little circle is pin 1. I stuck the black side of the probe into a ground connection. I used the ground connection that is on the screw terminals. All right, so I just screwed the black side in, and then just went probing with the red tip. Right now, to be able to do this properly at this pitch, um, I'll show you something really quick. You will probably need some decent equipment. So you see this here? You went these on Amazon. That is like a really fine pitch probe. This is probably what you get what comes in the packet, right? If you buy a multimeter, you'll get this. But you see, this little attachment here will go onto this and turn it into a fine pitch probe, right? So really cool and frankly kind of needed at this pitch, right? I'll show you in a second. We'll just go back to the scope. Right, so let's say you're trying to probe and you've got your one side is in it and then you're like, okay, which of these? Now you could get in there, right? But eh, it's kind of tricky, right? Am I hitting? I mean, you would eventually you'd figure it out, right? Because you'd hear beeps for ground or whatnot. But then if you bring in this guy, right? Now I know exactly which pin I'm hitting, right? So anyway, so I went around and I found all the grounds that it listed. And then I found an extra ground, which was called XT, XTAL, right? So we'll go back to the Firefox, right? So let's look at this and see this one here, XTAL1. So XTAL1 was beeping as if it was connected to ground. So um, that stands for crystal. So that's the crystal that's providing it's providing the clock signal from the crystal. So it was connected to ground. Um, and so what I did then was let me just go back and show you. I was like, okay, well then something connected to the crystal must be grounded. And so, here's the crystal. Okay, here's some caps near the crystal. Here's a resistor. And so I just turned the board over and fair enough, or sure enough, uh, oops, sorry, let me just come back a little bit. Um, one of the caps was grounded, but like the pins were touching. Okay, I brought in some rosin flux, got in the soldering iron, fixed that, and then the programmer communicated with it. Okay, so just a little, useful little tidbit of information there, maybe. If you've got if you've messed up your soldering or if you've messed up your pieces, then or messed up your soldering or you've grounded two pins together, it might manifest at the chip first. So you can check the pins of the chip, then find out, well, where are those pins going, and then you actually might find out then um, which of the components you've actually shorted to ground. Um, which, you can see here that the switches, like there's a bunch of stuff. The switches are going into this little, um, this side, right? So if you grounded one of the switches accidentally, then that chip would. So it's kind of a central place to check for bad ground. So that's where I started. First ground I found was the only one, and then everything seems to be booting up, as regards the chip, as in the programmer can talk to the chip. Now here's your programmer, okay? So this is a let's go back and look at this. It's actually not a great programmer. It is a let's plug it in. It is not a fantastic. It is a PGM03A, very basic programmer. Um, and so what you do is, well, I guess the good news about this one is that it doesn't have any power, so you can't accidentally bust your board by applying power twice, because I don't think this one has it. So, so step one, so what we're going to do is we're going to set the internal fuses in the AT25 Mega, and I'm going to show you a couple of ways to do it. So step one, we're going to attach the header. Now, you might ask the question, why is this not attached? In the guidebook instructions, it says take off the LCD reader or the LCD when you're doing this. So this is very first boot of the very first firmware setup of the device. The AT2560 is completely blank. And so the fuses have to be set so that they work properly with the crystal and set the speed of the CPU. So you have to do two steps: flash the firmware, and you have to set the fuses. Okay, and if you look in the booklet, there's just many, many, many different ways of doing this. Okay, so let's go. Let's go look at the book, and then we can check it out. Okay. Um, well, before I do that, let's let's just plug in the power. So before you do any of this, you're going to have this booted up. Okay, and I'll show you how to install that. I'll just give you some brief overview of how I installed that. Okay, so now I've got this here is powering the board, and now I also have the programmer is ready to program the 2560 Mega. All right, so we go back to our Firefox. Okay, and I guess I'm in blank mode. Let me see. What are you looking at? Okay, so you can you can kind of see things. Sorry, I'm a little bit snuffly. Okay, so we're going to come out of here back to the. It's a massive document. It's like I don't know how many pages. Um, so okay, so this is what it should look like when it's done. So we're going to go in here now. Programming the tester, fuses and firmware. Okay, so programming the tester. So I have a Pololu. I have a Pololu programmer. It's like 15 bucks, like or 20 bucks directly from Pololu. They sent it to me. I didn't want to mess around, so I just wanted to get it directly from them. I bought the Pololu. There's several different versions. I think I bought the most basic version. Um, and you can see here from many of these programmers, it says don't plug in the USB and the header at the same time, because the USB provides power and sometimes the programmer provides power. So you might want to just, I guess, check to see if whatever programmer you're using, when you plug that in first, see does this thing light up, and then don't plug in the USB, because apparently it'll be a bad idea. Look at all these warnings. It says do not do it. Well, actually, these warnings don't say do not do it, but there is other areas that say do not do it. Okay, so programming the fuses. All right, so use this program called AVRDude. Okay, you'll have to go to GitHub to get that. So here's this AVRDude GitHub. If you're on Windows, you can just go to releases and, whoop, sorry. There you go. See, look, Windows ARM 64, Windows x64. So that's what I used. It's a 64-bit Windows I'm using. And then that will download and bring you the AVRDude binary. So then what you can do is you can go to your command prompt, right? So let's just see if I can bring up the command prompt here for you. Okay, Firefox full with command line. All right, so now I have my command line here. Okay, so let me just see, is this working? Sorry, I need to put this up. I need to get my keyboard. All right, so now if I type here, see what the latency is. Okay, now for whatever reason, as I'm typing there, you didn't see it, so I wonder why that is. Is this a different window I'm showing, I wonder? Okay, command line. Um, Strange, it doesn't seem to be, yeah. Is it because I'm on, oh, I see what I've done. It's on power, it's power thing, all right. All right, so you see here I downloaded AVR dude and then I can execute it, right? So let's see if you're seeing that. Yeah, yeah, yeah. Okay, it's all working for you. Now, um, okay, so now then what we have to do is we've got to go over to the handbook, and then you've got to copy these commands. Now, for whatever reason, the way he's done this, I wasn't able to actually copy that directly out of there. But basically, um, this does, you know, it will set diffuses. Now it'll try to connect to the AT2560 mega. If it can't get to the mega, it's going to start giving you trouble, which means, you're going to have to go back, make sure that the mega is alive, test the VCC voltages on the mega, make sure that it's alive. Um, so if you're at this step, you should be sure that your chip is alive. So, okay. So I'll tell you what I'm going to do. Let's go and type in this command. Okay, so let's bring this down here. Okay, and I'm just going to go back. Right, right. I just want to see what I want to see what you can see. Okay, so here we go. So we're going to do AVR dude .xc minus C AVR dude. Oh, I guess. Well, I guess it's not going to autocomplete dude.conf. All right, let's just run that just to see what happens. Okay, something's happening. Minus V, which I guess means verbose, minus pat mega 2560. Now minus that. Now what that is minus P AT mega 2560. So I think it's just he's concatenating the um, the commands here. So it's minus V verbose, minus P for processor, so minus P AT mega, um, minus C, which is I think the standard maybe. Let me see, SDK 500, so SDK 500, um, and then minus P. Now I know mine is on COM4. All right, so let me see. Can I show you my device manager? Okay, so in my device manager, once you've installed this, it'll show up when there's Polu USB devices. Now, I don't know if you can see this then. Can you? No, you don't see it when it pops up. But it's COM4, COM5 is what shows up on my computer as the possibles. COM5 is a TTL port and COM4 is the programming port. But if you go to, you can't see it now. We just right click on this Polulu USB or VR programmer, go to details, and then actually, no, sorry, that's not what I want. You right click on the COM port and go to details. And then if you scroll all the way down, there'll be a, I'll tell you what it is. It's, well, uh, bus reported device description. Go to bus reported device description, and then bus reported device description here on COM port 4, it says Pololu USB AVR programming port. So I know that that's the right port. That's how I did it. I'm sorry I can't show you this because I'm terrible at OBS. Um, but yeah, we will just leave that there. Now, so back to command line, right? I'm going to show you another way to do it in a second too. Okay, so now we're writing hex values to the view to the device. Okay, so lfuse or dum dash colon I minus u h view. So these are like high and low bits that we're writing. R comma or semicolon or and then I, and then the last fuse minus u e fuse. And by the way, we're only testing communication here. I believe what we're doing is we're just reading the values from these fuses. Or semicolon dash semicolon I. All right, let's see what happens. There we go. It looks like it worked. So reading HFuse memory, reading eFuse memory, and then it's printing out the hex values that it found when it did it. So let's just scroll back up and look at what happened. It said version found device on COM4. All right, block poll, blah blah blah. Firmware AVR device initialized and ready to accept instructions. So that's what you. If you don't see that, I don't think the 2560 is working. And then it starts reading the fuses, right? So it read all 3 fuses. Okay, that's good. Now, let's go back to the instruction book and see what's next. Okay, so you can see similar output to what we saw. And now we're going to change, instead of reading, we're going to write. Okay, so let's do that. Okay, so PCOM4 LFuse. Now we're going to go back. So LFuse, we're going to change the read to a write, and we're going to write value 0xF7. Okay, and then minus UH fuse, we're also going to do a write, and we're going to write 0xD7. All right, and then we're going to update the eFuse W 0xFF. Now, so again, this sets the modes of the fuses, I guess. I'm not a AT2560 developer or don't develop on this stuff, so but it is very important to operating this retro chip tester, and apparently it sets the speed of the CPU, I think, and makes it work correctly with the oscillator or the crystal. So, all right, so that's it. We're writing 0xD7. All right, let's see what happens. Okay, so this these writes worked. So again, we just saw the same output. Now we're doing some writes. Okay, so now we can move on to, all right, so it says batch file. There's another way you can do it. I'm going to show you one more way that you can do this, and this is by using a program called AVR Dudes, which I guess is the female of AVR Dude. And this is another program which could do just what I said, but it's actually a little easier. So check this out. A little easier than what I just did. Okay, so we are going to. This is in fact how I wrote my firmware. So I'm going to write my firmware using AVR Dudes as well. Okay, so AVR Dudes, you can download. I think it's another GitHub project. Very simple. Download it, install it, and then off you go. But when you install it, you will end up with, um, what will you end up with? You will end up with this program here. So this is AVR Dudes. Okay, now what we want to do here is the same things we did before. So for this Pololu, you select the STK 500, probes V2, then first MV1. I know it's on COM4, no baud rate, no bit clock. Pick the AT2560 here. Okay, now as soon as you've done that, right, you can read the fuses. Okay, so watch this. All right, red high fuse, and now it's put them in here. See, it's actually read them and put them in here. Now, if I wanted to write them back, I can just tick or untick set fuses, and I can click write. Watch. Okay, AVR do done. Okay, so that's all done. But the really cool thing, you don't need to worry about all this stuff down here. Up here, you'll see that I actually have my firmware, my hex firmware. Just pick write, leave these alone, and then just press go. And this will flash the firmware onto the this will flash the firmware onto the retro chip tester. So that's basically, you know, that's it really. You know, you just kind of go and do that, and then you've got your retro chip tester flashed. It takes about a minute to write it and then a minute to verify it. So pretty good. And then after you've done that, you should be able to reattach your LCD, and then you should be able to your um, boot your retro chip tester. And that's it. About, I guess, in total, although it took me too long, about 12 hours of work, 13 hours of work, um, which is a lot, but I think it was a lot of fun too. Um, One thing I want to do is I want to fix an old OSSC that I have. I want to take that thing down and have a look at it. Um, we might be able to make that work, because I think we're getting close to this one now. So now it's wrote uh, the the firmware to the to it, and you just download this. What you download the firmware directly from 8bitmuseum.de. So 8bitmuseum.de has the firmware. You just download it, and it gives you a file here. You see, I just browse for it. Blah 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 .hex. I'm installing 0.27, which is one of the latest. Um, and from there you can operate the retro chip tester. AVR dude done. Sweet. Okay, so I will stop that now. So that's the firmware and everything done. And the instructions for doing that, let me just show you. So we're going to get rid of the command line here too. Okay, so the instructions for doing that are also down here. Okay, there's a lot of good troubleshooting stuff in this document. It's really good. Um, I'm not using that DC to DC voltage thing. SD card reader, I haven't tried. Experiments, blah, blah, blah. Let's keep going. All right, it starts talking about all the different programmers and how some of them totally do not work. There's our printout of the ATmega. You might need that if you've shorted anything. Okay, looks like now that's just showing you how to test things. Problems with the display. Well, I guess we'll see in a minute if we got problems. Yeah, some other stuff here. Okay, let's just put it in and see what happens. Okay. All right, I wanted to just show you where he was showing about the programming of the particular for like the instructions that I just went through. They're down here in one of the pages. Yeah, so here, look. So this is the Pololu USB AVR Programmer 2.1 on Mac OS 10. And then down here, he has it for Windows, I think. Yeah, for Windows, you see. So remove the LCD, blah, blah, blah. Um, I don't have to worry about disabling the VCC output because I don't have the modern one, but that's very important. Otherwise, you might break something. Um, and then he shows you how to do it with AVR do this. Is exactly what I did. So there you go. So you can do it either way. All right, now let's go back and look at this, and then I'll go in for dinner. So we are going to bring out this. All right, let's switch back. All right, so what we're going to do now is we're going to pull out all the power because now we're going to have to start putting this LCD screen on. All right, so I have previously shown you how to do this, so there we go. There's the LCD is on. We will screw the LCD on just so that it's secure and not bouncing all over the place. Oh, okay. Okay, so there's number two. I think we can actually do it out this thing now because there's no shortable stuff underneath here. Plus, I put some standoffs underneath it too, which you can also do. Just check what I did there. So it shouldn't be, the back of the board's not touching the ground anymore, or touching the desk. All right, so this looks pretty good. A little bit of wonkiness with the thing. Now, okay, so you see that's quite sturdy now. All right. All right, so let's boot it up and see what happens. Nice. Okay. All right, let's take off the... Yeah, all right, so that's cool. We've got the little plastic cover for this. Now selected SRAM's common. Now these are like little joysticks. I was playing with them earlier, so I guess I could go like... Oh, and it makes a sound. Okay, hang on. Can I turn that up? Oh, let me... Actually, I want to try something else too. Can I try the contrast button and see if contrast works? Yeah, let me just try the contrast, right? Oh, oh, interesting. Oh, I'll set it so that it shows up best on the screen. Too much. Yeah, that's best. That looks okay on my end, but actually really good on the screen. Doesn't look as good here. That looks better here in person. Okay, so select custom definitions, logic PROM. Can I turn up the... Oh, I can't turn up the volume of that thing anymore because it's underneath the... Well, I think that's what that trim pot was for. I thought it was for volume, but maybe I'm wrong. Anyway, it's loud enough. FIFO DRAMs. So what would I do? I press OK, and then it says selected, tested, pre-test again, testing failed again, right? So obviously I have no chip in here, right? So you have to sort of have the right stuff here, and you would put a chip in here, and then you would be able to do things and do the breakout board and blah 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 blah. So selected. Oh, look at this. Yeah, it's just like crazy stuff. Okay. Exit. Okay. All right, now back to the top menu. Okay, so there's a service menu here. Where did the service menu go? There's info. US URCT chips 200 of 1042. Oh, selected self-test. How do I do that? Oh, That's okay. In the manual, it says the self-test will fail because I don't have the other two jumpers on. But um, that's interesting. I'm not sure how I did that. Enter, what's enter config? Sorry, I just want to see what this is. Oh, I see. Fastkey chip detect. Wow. Okay. All right, let's reset it. Okay, reset works. Oh, something happened there. I don't know what happened. Okay. Huh. Okay, I'll have to look at and see exactly how it works. But that's pretty much it, Chad. It actually works now. So so I've did 11-hour stream yesterday of building this thing. It actually works now. So pretty cool. I'm pretty proud of myself. That's like I don't know what it was. Like is that 100 components? Maybe more. Um, Maybe more than 100 components. But anyway, whatever about it, it's working now and programmed and all from scratch and all from a bag of parts from DigiKey. So, with all intents and purposes, I think I've done a pretty good job here of just making it work. And yeah, I think what I need to do now is 3D print a case for it, which I don't have. But for now, this will go up on the shelf, and it's a functional tester, I guess. And I'll need to obviously run maybe some more tests on it just to make sure that it will work for some of the chips that I have. Maybe we'll do that in another video. But generally, like I'm pretty happy with this. Um, and so yeah, these are quite cool. Everything's quite cool. Yeah. So obviously, yeah, when it's not testing, it's not going to get hot. All right, and the barrel jack is there, but I don't use it. Yeah, that's everything. Okay, I might come back later tonight and do some more stuff. Please follow, like, and subscribe. Um, but yeah, this is the retro chip tester. So roughly a 13-hour build, I would say, from scratch, including soldering the AT2560 Mega, programming it, and removing a ground fault. So yeah, if you're bored on any day and you want to watch 11 hours of somebody struggling to solder something together, you can go back and look at that stream too. So yeah, this is really cool. I'm so happy that this is done now. I'm actually surprised that it actually worked. So I thought that like I would have totally messed up something here, but I went around and checked my wiring and checked my soldering, and it looked good this morning. So I guess I got lucky. Um, all right, folks. Well, that's it. I want to put this in a little bag so that I don't damage it. Take care, and I will see you on another time.